Many of you are actually familiar, may actually be familiar with our technology, especially if you have kids. How many of you have seen this already?
Hello, I am Baymax. Tadashi programmed me to heal the sick and injured. You will be all right. There. I would like to help. Scan complete. You are experiencing mood swings. Diagnosis, puberty.
Whoa, what?
It's like spooning a warm marshmallow.
What do you say, buddy?
So this, of course, is Disney's latest feature film, Big Hero 6, and it's about a movie about an inflatable robot that is designed to be a healthcare companion, but of course a supervillain attacks, and it has to try to save the world. But that's not actually the point. What's interesting about this movie is they've shown us a robot that naturally interacts with the world safely without even trying. No control systems help it do that. Just because it's soft, just because it's compliant, it is able to interact with everything around it, and you don't even have to worry. When you watch this film, you totally understand that people would be able to interact with this robot. This movie was, in fact, based on the technology from here in Otherlab, and that's how that Hero 6 came to be. But before Hero 6, you don't see robots in a world like this today. This is what you see in the world today. This is a manufacturing line. This is an automotive manufacturing line at a Ford plant. And these are big KUKA robots that are doing welding and assembly. And these robots basically are made out of rigid metal linkages. And because of that, they're very heavy, they're very expensive, and they're dangerous to be around. We have to bolt them to the ground, we have to quarantine them off from people, and we have to always bring the tasks that they're going to work on directly to them. We want to change this. Pneubotics is a new class of robot that doesn't have to have the task brought to it. It can go to the task. It's entirely constructed out of compliant skins. It's pressurized with fluid to give it motion and strength, and it has no metal whatsoever inside it. This is just fabric and air, the robot you see on here. This is a controlled prototype that we did in the DARPA program that Saul mentioned. And so this robot, as a side effect, is inherently safe to work with the world around it. But what you might not expect is this robot is actually stronger for its weight than traditional metal robots. And that's because most of the high-performance material, the highest performance materials that we have access to today, are not rigid and are not metals. There are things like carbon fiber, Kevlar, and Spectra. But what we do as engineers is we constrain ourselves to this small sliver of space of rigid design. And this is because we don't want to deal with the dynamics of compliant materials and soft materials in operation. What we want to do is we want to design with rigid materials. We want to ignore the properties of materials during operation. Today we have the ability, we have the control algorithms that we're developing here in Pneubotics, and we have inexpensive sensing and computation that makes it possible to access this space and use softer materials in our engineering designs. These are materials that don't have to be a lot softer. These are materials like polymers, like blow-molded PET or woven nylons. We have access to the space, and because of that, we can now trade off material complexity, weight, and cost for inexpensive sensing and computation. If we look at the space of robots out on the market today, we can see the effect of our limitation, our use of rigid material, and how it's constrained the industry. This is a plot of the economy of robots versus their mobile lifting capacity, and it tells a very important story. These are all the robots you would find on the market today. When we compare them to where human labor is at, we find that they actually beat human labor on economy. And it's very clear that when you can bolt them down on a manufacturing line, you can become much more efficient. But what humans are still the gold standard for are mobile lifting capacity. We are much stronger for our weight than traditional robots, and this allows us to go out into the world and do manual tasks. And most tasks today, there's a lot of tasks today that are still done that way because of this metric. What you need to do to build a robot that can get outside of the factory is you need to have the efficiency and economy of traditional robots with the mobile lifting capacity of humans, and that's what we're building at Pneubotics. This is where we sit in order of magnitude on both metrics, which allows us to go to new environments that might look like this. This is industrial cleaning, where you need to put a robot in a rough environment. We are completely sealed robots that are non-corrosive, that you could hose down at the end of the day and bring to the task like this. Similar thing with commercial finishing, where a robot might need to go to a difficult location. Agriculture is an enormous opportunity that is completely dominated by manual labor and is losing billions of dollars of produce that is left on the field due to lack of labor availability right now. And finally, warehousing is a huge near-term opportunity, and this is where we're going first. The dynamic in warehousing today or in the past has always been pallets, and it is shifting now to individual boxes due to things like on-demand fulfillment and e-commerce. But we don't have good tools to lift boxes. We just have tools for pallets. And so right now, all of this is done by manual labor. We're the first company that's going to change this, and we're starting with heavy items because we have the highest lifting capacity for our weight than any robot that's out there on the market. We're building robots that can be retrofitted to standard pallet jacks and put on the floor of warehouses later this year. They're going to be able to lift, to help team lift tasks, which is where you're lifting between 50 and 150 pounds, and you need 2 people to do it. With our machines helping you out, you will only need 1 person. This is helpful for managers. This takes the burden off of the lifters. It makes them more efficient, and it makes them happier. This is a huge win for warehousing. This is a huge win for robots getting outside the factory and starting to enter the real world. Hope you guys come and see some of our demos and get your hands on back at the booth back here. We'll be happy to show you just how safe they are. Thanks for listening.